Good morning. Today we are going to continue our basic mathematics series, and this morning we'll be looking at power of natural numbers, natural numbers. Basically, when we talk of power of natural numbers, the commonest thing that comes to our mind is indices or exponential numbers. That is the simplest way this can be expressed. So it's either indices. Okay, indices or exponential numbers. To talk of exponential numbers, they are the number of times a figure will multiply itself. So if number 2 multiply itself by 3, let's say 2 is multiplying itself by 3, that's the number of times 2 is multiplying itself, then this one will be written as 2 to the power 3. In the same vein, instead of saying 8, 2 times 2 is 4, 4 times 2 is 8. So 2 to the power 3 is what? 8. So when a number is expressed in the form of a base, we call this one base. Number is expressed in the form of a base and a power. We call the number exponential function. It is the basis of mathematics, and before we'll be able to understand topics like algebra and the rest, this topic must be fully understood. We will start by looking at how to convert whole numbers to power and base. We're looking at how to convert whole numbers to a power and a base. Basically, when you are being given any number, to convert that number to a power and a base, what you have to do is first, you look out for the least number, the least factor of that number. Then look at the number of times that number can multiply itself into getting the whole number. For instance, now I've been given a figure like, let me say 16. Now, how do I convert 16 to a power and a base? I must look at the least number that can divide 16, apart from 1. 2 is the least number that can divide 16. So, first, 2 goes to 16 8 times. Then, 2 goes to 8 4. 2 goes to 4 2. So, in this case, we've got 1 2 3 4. Giving indication that 2 to the power 4 is equals to what? 16. What do you mean by that? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is what? 16. So 16 equals to 2 to the power 4. So let us look at the exponential laws. Let us look at the first law of exponents. So the first law says that when you are multiplying two variables, if the base happen to be the same, you add the exponents. When you are multiplying two numbers, when you are multiplying two figures, variables or numbers, if they have equal base, you multiply and you add the exponent. Let me put this. So we say when we are multiplying figures or variables, if they have the same base, we add the exponents. So let's see, I've got Now look at it here. I've got a to the power m, a to the power n. Because the base is a here, and the base for this one is a, then at this instance I can say, because of the base being the same, we will add the exponents. For instance, if I've got 2 to the power 3, what do we see? Because of equal base, we will have 2 to the power 5. The base are the same. Another way around, if the base are not the same, you cannot add the exponents. Okay, so we said if the bases are not the same, put them together. What do you mean by if the bases are not the same, you put them together? For instance, now look at it. We can clearly see that this is 3, this is 2. They are numbers. We can easily multiply them. This is, you just have to look at it. This session will be explained very well when we come to the aspect of algebra. This one will be handled, but you need to understand it from here. 3 and 2 are numbers, so you first multiply 3 and 2, which will give you 6. Then a is to the power 2, b is to the power 2, but a and b are not the same. So what I will just do is that I'll put a squared, b squared together. I'll just bring them together. So this gives a clear indication that when you are multiplying and they are figures, just multiply the figures. But if they are variables, put the variables together. Let us look at 3, third law. So we said when dividing exponential figures and their bases are the same, subtract from their exponents. Let's see an example. We have we have 3 to the power 5. Always you subtract, this one is the divisor, or yes, the divisor or denominator. And this one is called dividend or the numerator. This same is the same as in this case, because they have equal base, the base here are the same. You said you subtract from the exponent, so you pick a common base. What is the common base? The common base is 3. So I'll just write 3, 5 minus 2. And this will give me 3 to the power 3. And 3 to the power 3 is the same as 27. 3 to the power 3 is the same as 27. On the other hand, if the bases are not the same, so we clearly see that when we divide it, and it's 3 to the power 5 divided by 3 to the power 2, is this equivalent to this from the initial explanation? You're giving me 3 to the power 5 minus 2. And that is 3 to the power 3, which is the same as what? 27. Then we come down here to say that when dividing and the bases are not the same, leave it. For instance, (3a squared divided by 2b squared). You can't do anything about it, so this one will still be equals to simply because Yes, you can't do anything about 3 and 2. The best you can do is to change 3 and 2 to mixed number. But a squared and b squared, they don't have any bearing. So in such case, you just have to leave it like that. Okay, we go on further. Mathematics questions are mostly asked with a combination of the law of multiplication and division of exponents. Good. In situations like this, you don't have to get yourself confused. You have to apply both laws differently. So you have to work all the multiplication using the law of the multiplication and go to all the division using the law of division. When you finish, you combine the multiplication and division to be able to get it. Let's say an instance. We have a question like, it says, if a equals to 2 to the power 2 times 2 to the power 3, if a divided by 3 to the power 4 find a. This is the question. If a equals to 2 to the power 2 times 2 to the power 3 divided by 2 to the power 4, find a. So how are we going to get our a? You know, this aspect is multiplication and this aspect alone is division. And the product, they work together. So in this case, I'm going to get a to be equals to, just look at the multiplication, because they are together, you work them together. This one is going to give me, let me just go 2, according to what we have learned. We take a common base. There's 2 here, there's 2 here. And when we are multiplying, we add the exponent. So I'll take a common base of 2. Then 2 plus 3 as my exponent. Now divided by 2 to the power 4. Now 2 to the power 2 plus 3 will give me what? 5. So I have a 2 to the power 5. 2 to the power 4. And now you see it has now become very simple. We see if the base are the same and we are dividing, we subtract from the exponent. So I'll now subtract the 4 from the 5. So I have a to be equals to, we don't say 2 to the power 1, it's 2. So the value becomes 2 at this instance. Let us look at more examples. Let us look at these questions one by one. So the first question says, we are supposed to find m if 3 to the power 6 divided by 3 to the power 4 times 27 is equals to m. What is the value of m? So we can look at m in that regard. We also go further. So simplify 6 to the power 2 divided by 2 to the power 2 times 3. We also go further. I say simplify 36a cubed, a to the power 3, b squared x divided by 27 a b cubed y. So we are going to look at it one after the other. So we look at solution. If you try to pause the video to see if you can try your hands on the first one. Okay, so we see m. We are fortunate, if you can remember PEMDAS, we got or board mass, as we would call it on our part here, but those in the Western world call it PEMDAS. So we got the one in the bracket must be considered first. So judging from that, we have $27. we can see that 27 has been given as a big number. So as we did earlier, we must find means to reduce 27 to its base and power. We have to find a number that can go into 27 in that division line to be able to get the 27 also to a power and also a base. So this one is going to help us to be able to work on that. So for here, I have my m. The first part gives me 3 times 27. Let's work it out before we bring it here. Let's work the 27 out before we bring it here. So going to work the 27 out, I go rough part of mine. Let's say rough part, 27 here. Because I have a base of 3 here. I have a base of 3 here. So the 3 base must be my guide. So it means that the first figure I will try to use to divide the 27 to change it to power and a base, I will try and see if it can conform with 3. So what I use is I first choose 3. So 3 goes to 27. 3 times what number will give me 27? 9. Good. And I still have to use 3. 3 will go to 9. 3. So for 27, I will have it to be 1, 2, 3. I've got 3 occurring 3 times. So in place of 27, this thing not needs to show in your work. So you got 3 to the power 3. So at this instance, we just subtract 4 from 6. We'll be left with 2 to the power 2. Sorry, 3 to the power 2. 3 to the power 3. So what do we have? We have m. Because the loss is that when we are multiplying and the base are the same, we add the exponents. So let us look at the second aspect. Now 6 to the power 2 divided by 2 to the power 2 times 3. Unlike before, most of the questions we have tried all have what we call common base, but this one is not having a common base. There is a base of 2 here. Anytime you see such, then the best thing you can just do is that you have to expand everything. Just expand it so that you cancel out like terms so that work will not become difficult for you. So this one is going to give me 6 times 6. That is 6 squared. 6 squared is 6 times 6. Now divided by, now 2. Here becomes 2 times 2 times 3. Good. So you have expanded everything to make it more easy for yourself. Now what we do now is this 3. 3 will divide 6 2 times. Have we seen that? Yes, 3 will go to 6 2 times. First. Then 2 will go to 2 1. If 2 is dividing 2, everybody will get 1. Good. Then this 2 will go to 6 3. So we get 6 to be equals to what? 3. So that one, 3 becomes the simplified. This one is simplified to get the final answer to be 3. Good. Let us look at the next and the last question. So we have to simplify this function. Okay, this time around, we were not given the numbers as the simple format of 2 to whatever, 3 to whatever power. But now we have 36 and 27. So the first thing we have to ask ourselves is, how are we going to break this to a power and a base? That is what we are supposed to know. So if we are able to know that we are going to be able to break this and also be able to break this, we will have a clue. So to break that, I still have to come here, 36. Okay, so 36, two numbers are multiplied, I will get 36. It's an even number, so 2 will go into 8. So 2 will divide 36. If it's being difficult for me, 2 here. 2 will go to 3, 1 with the remainder of what? 1. So it means that 2 will go to 3, 1. That means 2 times 1 will give me 2. If I subtract 2 from 3, I'll be left with the remainder of 1. So 1 here. That 1 is added up to 6, which will give me what? 16. So 1, 6. Then 2 will go to 16, 8. Because 2, 8 is 16. So it tells me that 2 will go to 36, 16. Again, 18 is still divisible by 2. So 2 will go to 18, 9. 2 will go to 18, 9. And 9 is not divisible by 2, but it is rather divisible by 3. So I'm going to get 3, 3, 9. So I've got 2, 2, 3, 3 from prime factors, a product of prime factors. So we have 36 will now be equals to 3 to the power 2 times 2 to the power 2. You see how I've expanded it? Then I'll bring my a cubed b squared x. Okay, as I worked for the 36, so I will do for the 27. So for the 27, the same way, I find the least number that can go into 27. As a matter of fact, 2 cannot go to 7, but 3, let's see. We have, because 2 is not a base, I'll try and see whether I can have 3. If I try with 3, 3 will go to 27, 9, 3, 9, 27. 3 times 9 is 27, so I've got 9 here. Then 3, 3. So it means that 27 is the same as 3 to the power 3. So I've got 3 power 3 a good. So we can now do this. Now we are now going to look at like terms and cancel. Look at it here. This one is to the power 2. And this one is to the power 3. This one is to the power 3. This is to the power 1. That is A is to the power 1 at the denominator. A is to the power 3 at the numerator. B is to the power 2 at the numerator. B is to the power 3 in the denominator. X and Y are different. So for them, we will not do anything. They will just come like that. So we first have to look at it one by one. We just have to work it somewhere and then simplify it further to get our answer. So we say when we are dividing, we subtract from the exponent. So this one divided by this. So the first one gives me, good at doing it here. 3, 2 minus 3. We can see that. Yes, this 3 is subtracting from this 2. Then there's no 2. So it means that 2 has no bearing, so 2 will remain. I don't have to worry myself about 2. Good. Then we have, once there's no 2, 2 to the power 2 will come. It's constant because there's no 2, there's no number that is competing with it, so that one will remain. Then I have a power 3 minus 1. This, just a is to having a power 1, but the power 1 we don't write it. So to the power 1, then we got b is 2 here and minus 3. The numerator is to the power 2 and the denominator is to the power 3. Then x divided by y will remain like that. There's one law you are supposed to know always bear this one in mind as you are going well before we bring our final answer. Just observe it clearly. When we got a to the power minus 1 is the same as 1 over a. It's an indicial law. A to the power minus 1 is equals to 1 over a. So if I work and I get, let's say, 2 to the power minus 1 is the same as 1 over 2. So we come here, according to this that I've explained. When I subtract this from that, I'm going to get 3 to the power minus 1. We will see how this one is going to be. Times 2 to the power 2. Then a, if I take 1 from 3, I'll be left with 2. Then b, I take 3 from 2, I'm left with minus 1. Then x divided by y. Know that they are all, it's all about multiplication, it's a product. So judging from what I have explained, a to the power minus 1 is the same as 1 over 3. This aspect alone is 1 over 3 times 2 to the power 2, which is the same as 4. Any number divided by 1 is that same number. Okay. Then times a also over 1. This is a squared. A to the power 2 over 1. Times b to the power minus 1 is the same as like this. A to the power minus 1 is equals to 1 over a. Then b to the power minus 1 will give me 1 over b times x over y. So the law says when we are multiplying, we multiply all the numerator together and all the denominator together. So what are we going to get? This one is going to give us, okay, 1 times 4 is 4, times a squared is 4a squared, times 1 is 1, times 4a squared x. So 1 times 4 is 4, times a squared will give me a squared, times 1 is the same, times x divided by 3, 1, 3, times 1, 3, times b, 3b, times y, 3dy. This one becomes your answer. You can't do anything about 4 and 3 because they are numbers and they are not the same. So in this case, you leave your answer in this manner. See how I explain this. You just have to look at it step by step and make sure you got the fullest understanding as you are using indicial equations. Indicial equations are equations given in the form of indices. In this case, you have two sides of the equation. If a to the power n is equals to say x, to be able to work out this, you first have to make sure that you change the x to have a common base like a so that you can equate it. For instance, we have a question like 2 to the power x is equal to 16. 2 to the power x is equal to 16. How am I going to be able to work out this? You are supposed to find x. How do I get x? To be able to get x, I must change this 16 to a power and a base. And we know how to change a number to a power and a base. So I'll take 16. I find two numbers I multiply, that will give me 16. You know, because the base here is 2. I will use 2 to do my division. So 2 will go to 16, 8. 2 times 8 will give me 16. Good. Then 8 is still divisible by 2. So I'm going to get 4, 2, 2. So we got 2, 2, 2, 2. The 2 is occurring 4 times. So we have 2 to the power 4. Yeah, 1, 2, 3, 4. So in solution, two to the power 4. So 2 to the power x equals 16. 16 is the same as 2 to the power 4. So what is the value of x? That is making it equal to 16. Then you can say x is therefore equals to 4. If x is 4, then the equation is correct. Good. Let us try more example of this aspect. Good. So we have these questions to contend with, since I don't think we'll be wasting much time on this. The first question is 5 to the power x plus 2 equals to 1, 2, 5. 2 to the power x minus 2 equals to 3, 2, and the same as the last one. Also 2 to the power 2x equals to 8. So we are supposed to solve for x in all the initial equations. So solution 1 or I. We got good. Because we have a base of 5 here, we must also convert this in such a manner that it will also have a base of 5. So we have to use 5 as our divisor approach. So I've got 1, 2, 5. How many times will 5 goes to 1, 2, 5? Okay, let's say 5 is here. We are weak in terms of trying to divide, not being so smart. So 5 will go to 12, 5 to 10, with a remainder of 2. So 5 to some, I'm going to get 2 here. 5 times 2 is 10. If I subtract 10 from 12, I'll be left with what? 2. Then 2 and 5 together gives me what? 25. And so it means that 5 will go to 25. How many times 5? It means that 5 times 25 is the same as 125. Then I'll go further to reduce this. This one is still divisible by 5. So 5 is 25. So in place of 125, I've got 1, 2, 3. That is 5 to the power 3. Equals to 5 to the power 3. Good. So if this is 5 to the power 3, then what we do now is, because the bases are the same, our concern is on the exponent. So you say you equate the base. Equate the base. So if I equate the base, I'll get cancelled out. Because say when we know the value of x plus 2 is equals to 125. So what is this and that? And that one is equals to the additional power. Our concern is not on the base, but say x plus 2 must be equals to 3. So how are we going to get it? It's about grouping like terms. Grouping like terms is letting variables on the same kind be at one place. So 2 is a figure or a number, 3 is a number. So let them be at one side, and let the variables also be at one side. X is a variable, so x will remain here, and 2 is a number. It will go to where numbers are, so it will cross the equal sign. Over here it is positive. When it crosses, it becomes negative. So I'll have, so what do I get? X is equals to 1. Yes, if x is equals to 1, look at it. If x is 1, 1 plus 2 will give me what? 3. And 1 plus 2 will give me 3, giving the indication of what? 5 to the power 3, which is equals to 125. 5 to the power 3, which is equals to what? 125. Let us look at the next question. So let us look at the second question, which is the II. The second solution. We've got 2 to the power x minus 2 equals to 32. It means that whatever x is, if you subtract 2 from it, you are going to get this 32, which will be 2 to a certain power. So first, what we have to do is that we have to convert the 32 into power and a base. And the base must be 2. So what we are going to use to divide 32 must be 2. So we have okay, so I'm breaking 32 here. So 32. 2 go to 32. How many times? Okay. 2 go to 3. 1. With a remainder of 1. Because 2, 1, 2. If you subtract 2 from 3, you'll be left with a remainder of 1. So this one will add up to 2, making 12. So 2 will go to 12, 6. Then I go further. 2 will go to 16, 8. 2 will go to 8, 4. 2, 2. Let me limit it since it's going off the screen. Okay, so we have 1, 2, 3, 4, 5, meaning that 32 is the same as 2 to the power 5. So we have 2 to the power 5. So this is what we have. Our concern is that when I subtract 2 from x, I must get 2 to the power 5. So what is going to be the value of x? Okay, so in this case, you equate the base. Make x the subject by letting 2 crossing the equal sign. Good, so we clearly see that the 2 is negative. When it crosses, it becomes positive. So 5 plus 2 will give me 7. So if x is equal to 7, then the equation is correct. Because it's only when x is 7 that when I subtract 2 from it, I will get 2 to the power 5. So when you finish, you can just put back to C. Mind you, all these examples are wire pass questions for BECE. So you are working more or less using the BECE question for your example. So just have to try and get the understanding to these examples I'm using. So we look at the last aspect, which is good. 2 to the power 2x is equals to 8. Wow. So what is x? It's x we are searching for. First, convert this one to a power in the base. For that one. So 8. 2 to 8 is 4. 2 to 4 is 2. So 1, 2, 3. 2 to the power 3. Good. So we got 2 to the power 3. At this point, what we do is that we equate the base. So equate the base, you are left with 2 to the power 2x equals 3. Now I want x not 2x, so I have to let the 2 which is attached to x cross the equal sign. And we say when multiplication crosses the equal sign, it becomes division. So we say you divide both sides of the equation by 2. So you divide here by 2. X equals to 3 on 2. So x is equals to 3 on 2. If you want, you change it to mixed number. But for such questions, we prefer you leave your answer like this for the final section. Okay. Okay. Now, the further initial equations are mostly given at the point whereby you will say a variable to a power and a constant, and the two are equated to a value. This is not quadratics. Quadratics function will come, but until we get to those and in algebra, right after this we are going to the algebra proper. So we have a relation like x squared plus 1 is equal to 50. Find the value of x. Find the value of x. X squared plus 1 is equal to 50. Find the value of x. What will I do? First to do is you have to let the constant cross the equal sign. So this is constant. So assuming you are grouping like terms, you let the constants cross the equal sign. So constant crossing the equal sign, you're going to get x squared 50 minus 1. And 50 minus 1. 50 minus 1 is going to give me 49. So I've got x squared is equals to 49. Good. Then how do we get x? Anytime you see a power 2, when a power 2 crosses the equal sign, it becomes root. Another way this one can be done is also multiplying through both sides by the reciprocal of the power here. But I know it will be difficult at that instance, so what we will just do is that we have to let the power cross the equal sign, and anytime a power crosses the equal sign, it becomes root. So you say you find the roots of both sides of the equation. Find the root of both sides of the equation. So I'm going to get the root of the power will be blown away by the root. The power will be blown away by the root. So as I cancel, I will get x, and the root of 49 is equals to 7. The root of 49 is equals to 7. So it means that x is 7. So 7 squared is 49. 7 squared is 49. 49 plus 1 is equal to 50. So anytime a power crosses the equal sign, you get the root. You can easily identify the root sign. If you know you are getting confused, you find you just have to look at two numbers you multiply to get 49. Then when you take the root, one, because it is even number, one will be blown away by the root sign. Okay, let us see further examples of this. So we got x squared plus 4 equals to 40. X squared plus 4 equals to 40, like we did earlier. Let the 4 cross the equal sign first. So 4 cross, we're going to get x squared equals to 40 minus 4. If I take 4 from 40, I'll be left with 36. X squared is equal to 36. Okay, so you would let the power cross the equal sign. This one becomes the root. So you have okay, so we just have to get root of. Okay, then you ask yourself, which two numbers multiply themselves to get 36? Which is automatically 6 times 6, which will give me 36. So it means that the root of it, the actual root of 36, where 36 is coming from, is 6. So we are just looking at the root when you talk of the root of Ghanaians, it's Ghana. Good. So we have got this cancelling this. So the root here becomes 6. It's perfect square. If it's not perfect square, I would have used the plus or minus. I will explain those when we are doing the algebra. So basically, this part is supposed to be fully understood before we start the algebra. Our next lesson will be on the general aspect of the algebraic expression. The algebraic expression is very broad. We look at algebraic expression and algebraic equations that will lead us to the linear equation, linear inequality, and the other function questions. So until we meet again, good afternoon.